Okay, welcome back. So before solving any heavy-duty linear equations, we want to become really good at this notion of simplifying expressions by combining like terms. So this will be lesson 12 for us today. We really want to hone in on this notion of like terms and the correct use of the distributive property. So let's begin. Vocabulary. A term that is just a number is called a constant, or simply a constant. A term that contains a variable is called a variable term. So here we have a variable term, and here we have a constant term. So 3x, negative 3x is a variable term, 18 is a constant. And I know that, it might seem that that's kind of elementary, but vocabulary is going to be really important as we see in a moment. The number factor of a variable term is called the numerical coefficient. A numerical coefficient of 1 is usually not written, it's inferred. So when you say x, you really mean 1x, right? When you say 5x, by the way, when you say 5x, you really mean 5 times x. Those are connected by multiplication. 5 is the coefficient. When you say negative 7y, this really means negative 7 times y. Negative 7 is the coefficient. And again, when you say 3y squared, that really means 3 times y squared. 3 is the coefficient. Just practice identifying the coefficient. All right, now let's discuss what makes like terms, because you continuously hear authors of textbooks say combine like terms, right? So terms that are exactly the same except that they may have different coefficients are called like terms. So, 3x and 2x, those are like. They have the same variable, different coefficients. Negative 6y, 2y, and y. All the same variable, different coefficients. Negative 3 and 4, well, those are constants, but they're considered like terms, okay? Unlike terms, let's talk about y. 5x and x squared. Variable, but raised, note to self, different powers. The variables are raised to different powers, so they are unlike. 7x and 7y, you don't even have the same variable. 5y and 5, you have a constant and a variable term. So these are all unlike terms. You would not combine them, in other words. Big note to self, though, these are like terms. Okay? The order of the variables do not necessarily have to be the same in order to be like terms. So when you say 2ab squared and negative 5b squared a, the commutative property says that, hey, you still have b raised to the second power. So, and multiplication is commutative, so the order of the variables doesn't have to be the same to be considered like terms. Okay, so this is a lovely little game I like to play. This table here. Let's circle. Okay, I give you the term 3x, right? And over here, if it's a like term, I want you to circle the ones that are like. So 4y, that's a no. That's not a like term with 3x. 2x squared, that's a no. Aha, 7x. Those are like terms. Okay, let's play that game again. 5x squared, and who is a like term with that? 5y squared? No way. Different variable. 8x? No way. Exponents don't match on the variable. Aha, 9x squared. That's a yes. And x, that's a no. So we're getting used to spotting the like terms, okay? 2x squared y. Who's a like term? This is a no-go, this is a no-go, and this is a yes. So just get good at spotting the like terms. Okay, little reminder on the distributive property. A sum or difference of like terms can be simplified via using the distributive property. And what this basically means is if a, b, and c are numbers, then you can take c and basically multiply it through the parentheses such as that and call it ac plus bc. And if you need numbers, think about it like this. C is a number, and a and b are numbers. Let's say 2 plus 5. It's legal to multiply that through and call that 3 times 2 plus 3 times 5, which is, 6 plus 15, which would be 21. So it's telling us what's legal to do, right? And we know that's legal because even if you cleaned in the inside of the parentheses, 5 plus 2 is 7, but then notice 7 times 3 is 21. So you are arriving at the answer. Now let's apply that. If it's legal with numbers, it's going to be legal with variables as well. Let's try it. And by the way, an algebraic expression is considered simplified when all the like terms have been combined. All right, so apply the distributive property for this one. Okay, so we'll have 2 times x minus 2 times 8y. Well, we can write that as 2x minus 16y. And that's it. Stop. Knowing when to stop. I can't go any further because x's and y's are not like terms. They don't go together, right? So 2x minus 16y, and that's it. Notice we're not solving an equation. We're just practicing, this is big right here, simplifying by combining like terms. Let's try again. This is just, here we'll just call this practice distributive property. That's all we're really working on there. So distribute the 3. Okay, so we'll have 3x minus 3 times 6. So that's 3x minus 18. And voila. That's it. Got to stop there. Those are unlike terms. One's a constant, one's a variable term. So you just got to stop. And one more. Send this through. So we'll have negative 2 times 4x. And then careful of the signs there. I like to keep that minus sign. I like to keep it. Then I like to say negative 2 times 9 is negative 18. But no matter what, negative times a negative then is a positive. So you could actually, I wanted to mention that, you could just read that to yourself. You have a negative 2 times a negative 9. So no matter what, you're going to arrive at positive 18. So note to self, careful of signs. Negative times a negative is a positive. Here, you're going to have negative 8x. So in the end, negative 8x plus 18 be your final answer for that one. Okay? Real careful of the negative times the negative is the positive. That happens a lot. All right, now let's throw it all together in one lovely dance move. We knew this was coming. So now we have these big algebraic expressions that make us use the distributive property and combine all the like terms. Here we go. As soon as you see parentheses, now remember this negative here belongs to the 3. So let's distribute. So it's kind of like negative 3 times y is negative 3y. You know, negative 3 times positive 2 is negative 6. You can say minus 6. Okay, minus 8x minus 9. Pin all the like terms together, meaning combine them. So 2x goes with negative 8x. And when we say combine, we mean like add like terms. So 2x plus negative 8x is negative 6x. And if it helps you, think of money. Think of money. If you have $2 and you lose 8, think of negative as loss. If you have $2 and you lose 8, you're going to be in the whole 6. Okay? Negative 3y, he doesn't have anybody to go with. But negative 6, loss of 9 for an overall loss of 15. So again, the constants, you can combine like terms there with the constants. And just do that mentally. If you've got a loss of 6 and a loss of 9, you've got an overall loss of 15. So nothing fancy there. So combine like terms really means add like terms, considering whether those terms are, positive or negative. All right. So even if you need to go off on the side and say 2x minus 8x, and just kind of think about that off on the side, 2x minus 8x makes negative 6x. And see, and that's how we were getting that negative 6x. But I would say, just think about it. You don't necessarily need to write it out. Okay? Let's try the next one. Distribute. Negative 4x. Careful, negative times a negative is a positive, so plus 32. Distribute. Minus 9x, and again, negative times a negative is a positive, so plus 18. When you arrive here, I'm happy, but you got to combine like terms. So I always map it out. Those are like. So negative 4x minus 9x, you have, it's like loss of 4, loss of 9, for an overall loss of 13, so minus 13x. And then, 32 goes with 18 to become 50. Right. So you combine the like terms there, and when you arrive here, you must stop. Why? Because we're not solving an equation, we're just combining like terms. So we combine the like terms, and voila. Okay, and final frontier, we got one more here. Hope you're enjoying this. You can always hit pause and try it before me. That's a good idea. 2x minus 3x. Careful here, negative times a negative is a positive. Keep recording. A lot of algebra is about recording your own thoughts in a linear way and in a concise way. 2x minus 3x, those are like terms. So 2 lose 3, you'd be in the whole 1. So negative 1x. These two are like terms. So if you have a loss of 4 and then a loss of 6, you've got a loss of 10. So minus 10y. And then notice the 24 doesn't have anybody to go with in terms of like terms. So we arrive here, and voila, you got it. So when you see simplify, you should really just think, long story short, you should just think combine like terms. And that's it. Nothing hard. Now, what's going to happen is we're going to take our concept of combining like terms, though, and apply that to solving some longer equations here very shortly. Good luck out there.